Everyone, so here is part 4. So in part 3 we left off talking about the law of conservation of matter, right, and how matter cannot be created or destroyed, neither can those atoms, and it results in the need to balance our equations to make sure we're actually using the correct amount of things in order for a reaction to occur. Because if it's not balanced, in nature it balances itself. If it's not balanced, then the reaction doesn't happen. So when we know a reaction has happened, then we have to balance it to make sure we're looking at the proper ratios of things. So one thing to keep in mind, when you're looking at a compound, which is a couple elements together, let's say we're looking at water, okay? This 2 here tells me that I have 2 hydrogens. The fact that there's no number here, chemists are really lazy, we don't write ones, okay, it means that there's 1 oxygen. Now, if I put a 4 here, this is called a coefficient. And this coefficient tells me that I have 4 molecules of water, okay? So if I have 4 H2Os, and water kind of looks something like this, takes on this shape. If I have 4 of these, and I were to count the actual number of hydrogens, it would be 8. Okay, and we can see that from our coefficient. If I were to multiply 4 times this 2 here, I would get a total of 8, and 4 times my 1 oxygen gives me 4 oxygens. And so we can use that, oops, my bad. We can use that to show how many is happening in each one. So let's look at problem A. So in problem A, we have ammonium gas producing nitrogen gas and hydrogen gas. So let's balance it out. First thing we gotta know is, what do we have? Well, our arrows separate things into the before and after. So I'm just going to draw a line there to show where I should be comparing. I'm comparing the left side to the right side. So there are several schools of thought for how you should write this down. So my totals, I'm going to have total of nitrogen and hydrogen. Okay, and I'm going to show you the 2 schools of thought, the 2 ways to do it. So for my totals, I can write nitrogen, hydrogen, and then write how many I have on each side on the appropriate side. So I have 1 nitrogen, and there's not a number 1 there because chemists are lazy and they don't write it. And I have 3 hydrogens. On the right side, I have 2 nitrogens and 2 hydrogens. This shows an unbalanced equation. Now, some people find this method, the way of looking at it, a little bit confusing. And so one way that some people have chosen to adjust is they split their workspace in half as well. And they keep their totals for each side separate. And so they would count nitrogen, we have 1, hydrogen, we have 3. Over here, nitrogen, they prefer 2, hydrogen, they have 2. Okay, and they keep it separate this way. I prefer the first route, and that's how I will be showing it in my videos and in class, but I wanted you to be aware that there is another way to write it down if you prefer this method. Okay, so let's go back. We have our totals, we have our elements listed, so we have nitrogen and hydrogen, and we know that they're separate because they're both capital letters. So we have 1 and 3, 2 and 2. We can see that this is unbalanced because I have 1 nitrogen on the left, but 2 on the right. Well, where did that second one come from? And for hydrogen, I start off with 3 and end up with only 2. Where did that third go, right? This reaction doesn't happen unless this is balanced. And so we are going to add these coefficients we were looking at earlier in front of the compounds in order to balance it out. So we can look at putting 1 in either of those 3 spots. Okay, so let's look at nitrogen first, and let's try to balance it out. Now, we said earlier that our coefficients get multiplied, and so we want to start off on the side with the smallest. 1 is a smaller number of nitrogen atoms than 2. So I'm going to look up at where I see nitrogen. I know that there's a subscript 1, so I need to think to myself, what times 1 can make my totals match? Well, if I put a 2 here, 2 times my 1 nitrogen will change my total to 2, and that's great. But this nitrogen is bonded with hydrogen. They're together. And so that means what you do to one, you automatically do to the other. So that means that this 2 must also be multiplied by my hydrogen. So 2 times 3 changes my total to 6. So my nitrogens are balanced. I have 2 on either side. But my hydrogens have 6 on the reactant side and 2 on the product side. So I come over to hydrogen, I say, okay, what times 2 will change my total to 6? And the number is 3. 3 times 2 is 6. And now I have a balanced equation. So you might be asking, well, what does that mean as in front of the nitrogen? Well, remember, chemists are really lazy. We don't write down ones, so we can leave it blank, which is how you would see it most often, or for the sake of our OCD, we can put a 1 there. Okay, so that's how we would balance this equation. Let's look at B. We can do the same thing. Let's split it and decide what atoms we have. So we're going to be keeping our totals under here. We have carbon, hydrogen, and oxygen. Now, the carbon on the left side, there are 2 carbons, 6 hydrogens, and 2 oxygens. On the product side, we have 1 carbon, 2 hydrogens, and here's the trick. Here we actually have 3 oxygens because oxygen is in 2 different places. It's right here and right here. So 2 plus 1 give me 3. That's actually something that a lot of people miss, so it's important to note. Okay, so, oops, accidentally erased my oxygen. There we go. Alright, so let's look at our coefficients. What should we balance first? I highly recommend leaving oxygen for last since it's split into 2 places and it will most likely be changing before the final balance. So let's start with carbon. 2 on the left side, 1 on the right side. So if I put a 2 here, 2 times my 1 carbon changes my total to 2, but it affects my oxygen. 2 times 2 gives me 4 oxygens plus this one over here, which is a total of 5. And now I want to change my hydrogen. Well, if I put a 3 in front of hydrogen, 3 times 2 is 6. 3 times 1 is 3, plus the 4 that are over here is a total of 7. Okay. So my carbons are fixed, my hydrogens are fixed, my oxygens are not. And if I have a 2 over here that I always have to multiply by, there's no way I can ever multiply anything by a 2 that's going to give me a 7 because it's an odd number. So one thing to do for that is if you're having a hard time with that, multiply everything by 2. So put a 2 here, well, everything except for the oxygen by itself. Multiply this by 2, so change it to a 4, and multiply this by 2, so change it to a 6. We wrote those coefficients so we can change them, so let's update our totals. We now have 4 carbons, we have 12 hydrogens, and then 4 times 2 is 8, plus 6 is 14 oxygens, and over here 2 times 2 is 4 carbons, and 2 times 6 is 12 hydrogens. So we can see that multiplying everything by 2 kept our balancing the same, but now I have a 2 oxygens, and 14 oxygens on the right side, which means I can easily put a 7 there in order to give me 14 total oxygens on the left side. And this gives us a balanced equation. Let's look at C. Okay, let's see how this one works. So we split it in half. We have K, I, Pb. And then one thing to note, well, actually, we'll just keep it separate. Nitrogen and oxygen. Let's count up what we have. We have 1, 1, 1. Okay, the 2 outside of the parenthesis gets multiplied to everything inside it. So we have 2 nitrogens and we have 6 oxygens. And then on the right side, we have 1 potassium, 1 nitrogen, 3 oxygens, 1 lead, and 2 iodides. So we want to see, okay, what coefficients can I use? So my potassiums are balanced, my iodine is not. So let's fix that first. So 2 iodines to 1 iodine. We'll put a 2 right here. 2 times my 1 iodine is 2. And then 2 times my 1 potassium is also 2. So let's go back to potassium, K. 2 on the left side, 1 on the right side. If I put a 2 here, 2 times 1 gives me 2. 2 times 1 nitrogen is also 2. And 2 times my 3 oxygens is 6. And so now if I look at that, hey, all of them have the same number before and after. So I can leave it as 1s in front of those. And that would be done. So that is a great thing to look at. Now, let's say we are doing a multiple choice test, right? Since you should be studying for one. Let's say you have 4 answer choices, and the correct one we're going to say is C. Well, let's say A is 4, 2, 4, 2, and B is 3, 2, 3, 1. And I don't know, D can be 2, 3, 2, 2. Okay, if we're doing this, the fastest way is to plug them in. So plug in each coefficient to see what it gives you. Now, a correctly balanced equation will always use the lowest ratio. Okay, that's important. It will always use the lowest ratio. So if we look, A will give us a balanced equation. It'll give us the correct number on each side. However, it is not the lowest ratio. It can be simplified. 4, 2, 4, and 2 can be simplified to 2, 1, 2, 1, which we know is our correct answer. If we were to plug in answer choice B or answer choice D, it would give us an unbalanced equation because my numbers would not match on both sides. So that is a just test-taking strategy. So why don't we move on to video 5.